We're working the following problem, Chapter 9, Number 11, and the problem states, the owner of Britton's Egg Farm wants to estimate the mean number of eggs laid per chicken. A sample of 20 chickens, that's N, shows that they laid an average of 22 eggs per month, which is X bar, with a sample standard deviation of 2.06 eggs per month. And the value of the population mean is unknown because it gives us the sample mean and the sample standard deviation, not the population mean. And the best estimate of the population mean value would be 22, since that's what they gave us.
C. For a 95% confidence interval, the value of T is 2.093. I got that from going to our student T distribution table and looking under 95% confidence interval, and also our degrees of freedom is N minus 1. So our sample size is 20. So 20 minus 1 is 19. Go down to the 95% confidence level, and we have 2.093.
The 95% confidence interval for the population mean is 21.036 to 22.964. The formula we used to find this was X bar plus or minus T over S over square root of N. In this formula, 22 is represented by X bar, which is the sample average. 22.093 is the number we found from our T table. 2.06 is the sample, or the sample of the standard deviation, and N is our sample number. Whenever we work this out, 22, we found that the number we were looking for was 21.036. 22 minus 2.093 times 2.06 divided by square root of 20. 22 plus 2.093 times 2.06 divided by square root of 20 gave us 22.964.
Next to question X, would it be reasonable to conclude that the population mean is 23 eggs, and also what about 26 eggs? We said no because it's not in the 95% confidence interval. That concludes our question.